My name is Captain Ashley Kessler. I'm on the teaching staff at San Jacinto College at the Maritime Technology and Training Center campus here in Houston, Texas. Objectives to how to fix your position by tangent bearings. At the end of this presentation, you will be able to, 1, define a tangent and a tangent bearing. 2, you'll be able to illustrate a tangent bearing. 3, you'll be able to illustrate where a tangent bearing is used in radar fixes. And 4, you'll be able to explain and demonstrate how to calculate the correct bearing from a tangent bearing to fix your radar position. What is a tangent? In geometry, a tangent line to a plane curve at a given point is a straight line that just touches the curve at that point. So this straight line would just touch the curve of this circle right here, and that is called a tangent. In radar plotting, when we find our new relative motion line to find a new course or find a new speed, we draw a new relative motion line from MX or execution point to the tangent of the new relative motion line. So at this point where that new relative motion line touches our required CPA, that would be a tangent. If you're plotting a radar bearing on a navigation chart and you take a gyro bearing on an island, that would also be a tangent bearing. So let's look at an actual Coast Guard question. It states the beam width of your radar is 2 degrees. The left tangent bearing of a small island, as observed on your planned position indicator scope, is 0.56 degrees per gyro compass. If the gyro error is 2 degrees east, what bearing would you plot on your chart? So information given in the question beside the gyro error is going to tell us that it's going to be a left or right tangent bearing. And in the question here, it's going to be a left tangent bearing, and it gives us the gyro bearing of 0.56 degrees. It also gives us the horizontal beam width of 2 degrees. So solution steps to finding a tangent bearing. First thing we have to do, we have to correct the gyro bearing to a true bearing. So our gyro bearing given in the question is 0.56 degrees. The question also gave us our gyro error of 2 degrees east. Since we are correcting our gyro, we're going to add the 2 degrees to the 0.56 and get a true gyro bearing of 0.58 degrees. Second step, we have to divide the horizontal beam width in half, because we have to add or subtract half of this horizontal beam width. So if we divide horizontal beam width by 2, the horizontal beam width is 2 degrees. You divide that by 2, our corrected horizontal beam width, or half of the horizontal beam width, is going to be 1 degree. Excuse me. And the final or third step, we're going to add or subtract half of the horizontal beam width to the gyro bearing. And the rule says we're going to subtract 1/2 of the beam width from the right tangent bearing, or we're going to add 1/2 of the beam width to the left tangent bearing. Since we're on the left tangent bearing, we will be adding 1/2 of the beam width, or adding that 1 degree to our true bearing. Two ways you can remember to add or subtract half of the horizontal beam width. If you remember the name LARS, L-A-R-S, L-A left add, R-S right subtract. So either add half the horizontal beam width or subtract half the horizontal beam width. LARS is a great memory aid for learning how to add or subtract a horizontal beam width. Another method you can use, if you think of a compass rose, this would be the right tangent side of the compass rose, and the numbers get smaller on the left side of the compass rose. We have 90, 60, 45, so the numbers get smaller, and some people know if I subtract the numbers as they get smaller, then I will subtract half a horizontal beam width. On the left tangent side of this compass rose, this is what we had in this Coast Guard question. The numbers get bigger on the left tangent side. 270, 300, 330, and the numbers get bigger on the left tangent bearing, so you would add half of the horizontal beam width. So you can use LARS, or you can think of a compass rose. So let's finish this question out. The beam width of your radar is 2 degrees. The left tangent bearing of a small island as observed on your PPI scope is 0.56 per gyro compass. If the gyro error is 2 degrees east, what bearing would you plot on your chart? So we calculated that the true gyro bearing is 0.58 degrees. Half that 2 degree horizontal beam width was 1 degree. And since we're on the left tangent bearing, left add, if you use LARS, we're going to add 1/2 of that, we're going to add half that beam width, that 1 degree, to that 0.58, and the correct answer is 0.59. So out of your 4 distractors on an examination, Charlie would be the correct choice. So to review our objectives for fixing your position by tangent bearings, first we defined a tangent and a tangent bearing. We illustrated a tangent bearing. We illustrated where a tangent bearing or a bearing is used in radar fixes. Explain and demonstrate how to calculate the correct bearing from a tangent bearing to fix your radar position. If you have any questions or comments about this video, you're welcome to email me at my campus email address, ashley.kessler@sjcd.edu.